Okay. The test tomorrow, I'm watering down the test if we can get it done in an hour. And so we're looking a little bit more at some of the basic concepts. So, here are some basic things you should know. Given parametric functions, you should know how to find the derivative with respect to x and the second derivative with respect to x. You should know how to find the length of a curve. Okay. And vectors. You should know how to add vectors. Find the magnitude and the dot product. You should be able to solve an airplane problem. Vectors. Be able to do initial value.
Is that length of a curve vectors or length of a curve and then vectors underneath? Okay.
Initial value problem. And projectiles. And then with polar curves, you'll be able to find dy dx, find area, and find length.
So no surface area for that one?
So no what?
Surface area?
There won't be any surface area, no.
Are you giving us any equations?
Giving you formulas?
Yes, please.
I don't think there's any there that you should have to be given.
Yeah.
What do you mean, yeah, there is?
Yeah, there were a lot of them.
Well, projectiles, given a projectile, that's something that's shot in the air at initial velocity at a certain angle.
Yeah.
Yeah.
You should know how to make its position. So, for example, what would its position be? It's going to have an x position, and it's going to have a y position. What's its x position?
I have no velocity,
Well,
velocity, cosine, theta, t.
It's whatever the velocity is, the magnitude of the velocity, times cosine of the angle, times the time that it's in the air. Okay? And then if there's other things, if there's wind, but I won't have any wind. Well, I will have wind, actually, yeah.
What? Oh.
But that would be in the airplane flying. We can do an example of that. No. This would be magnitude times sine of theta times t minus 1 gt squared, and then plus if the projectile was at some certain height. Okay, so those four, that you should know. I shouldn't have to give you that one. Okay, keep it down, keep it down. Any of theirs you want some more explanation of or an example of?
Airplane line.
All right,
Please.
Are we being tested on the 10 points that are stuff?
Very funny logos.
okay.
It's just length and not
Lengthen the area and derivative. All right, airplane. Give me an airplane. What's it doing? Flying how fast?
400.
400 miles an hour. And let's keep it easy. We'll just keep it. It's 400 miles per hour going east. So that produces a vector that's 400 miles per hour going east. This is your plane. What's happening? There's a wind. You want the wind helping it or going against it? All right, going against it. So you got a wind that's going against it. All right? What's the speed of the wind? 12 miles an hour. And we need to have an angle. All right, 45 degrees northwest. So it's blowing northwest 45 degrees. What's going to happen to the plane after an hour? Where is the plane after an hour? So what we have here is we have a vector that represents the plane, a wind vector going this way, which is 12, and the angle is 45. So we've got a plane vector, P, we have a wind vector, W. The plane vector plus the wind vector is going to equal a resulting vector. And the resulting vector would be this one right here. And so your task is to set up the vectors, add the vectors, figure out how fast the plane is now going, and what angle it's going at. All right? So let's do the plane. What's the vector for the plane? What's the x component? 400. So that's it. And there is no y component, so it would be 0j. What is w? What's the x component? Well, the x component is going this way.
12.
So it has to be 12 times cosine of...
45.
Okay, now you have to either do it one of two ways.
You can either make it a negative 45.
Right, you're going to have it a negative 45 or a 135, which would produce a negative value. Whichever gives you the negative, because you want the wind going that way. So just put a minus in front. 45. That's the I. Plus
12 sine 45j.
12 sine
45.
45j. Now this is not a projectile, so gravity's not playing a role here, because the plane is flying and not, it's not depending on gravity pulling it down or up. So we're just going 400 miles an hour east, and there's no gravity making it drop. Okay? Okay, now what do you do with those? You add them together. So the resulting vector is simply the sum of these two, 400 minus 12 cosine of 45i. And of course this one just stays 12 sine of 45j. Alright, would someone with the calculator help me out and give me some answers for that, please? Make sure you're in degree mode.
391.5.
Pardon me?
391.515 pi.
515 I plus 8 point what? 485 j. Okay, those are the components of the resulting vector. That is not the speed of the plane. What is the speed of the plane? The magnitude of this vector. So the speed of the plane would be the magnitude of the resulting vector. And the magnitude is the square root of each of the components squared. So you take 391.515 and square it. And you take 8.483 and square it, take the square root, and that gives you the speed. And it's what? 391.607 miles per hour. So that's the speed the plane is going. And actually, since this is not a projectile, that's the speed that it's going all the time until the wind changes its velocity or the pilot slows or speeds the plane up. Because you had it set at 400 miles per hour. Question?
So then, for the answer, you just say that it's 391.
Right, the plane is going 391.6 miles per hour, and the angle that the plane is now going at, because of the wind pushing it, is, well, this is a right triangle that has a component here of 391.515, and it has a component here of 8.485. And how could you calculate the angle of that? Using inverse tangent. So you go the tangent of theta is going to equal the components, 8.485 divided by 391.515. So theta would be the inverse tangent of that. And it's going to be pretty small, but maybe 1 or 2 degrees or 3 degrees or something like that that's off course. So that's how you would solve it using the vectors and the components. And it would be just, that would be that basic, that's straightforward. Okay? All right, anything else that you want a little more clarification on? Yeah, Jacqueline.
Projectiles?
Okay? Same thing, you just want an example?
Sure.
Okay. All right. We'll use Jacqueline. She just won her tennis match. She was excited. She smashed the tennis ball and did it go over the fence. All right? So here's our tennis court. How tall are fences? 15 feet. How long is a tennis court?
100 feet.
All right, just keep it simple. 100 feet. She smashes the tennis ball. All right. Okay. So, Jacqueline, she's hitting the tennis ball. It's probably 6 feet off the ground. When she hits it at an angle of 3 degrees. Well, yeah, she just hits it that way. She didn't mean to hit it out of the court. She just went to hit it. Okay.
But she underestimated it.
Okay. All right. 120 feet per second. All right. Okay. Does it get out of the court? All right. Okay, so we got a projectile here. We got the tennis ball. The tennis ball is a vector, basically, and the vector is going like this. These are all vectors, depending on the time that's left in the air. And eventually the vector is going to just end up down in front. All right, so we need an x component with time and a y component with time for the projectile. Okay, so what's the x component? Well, it would be the x component of the initial velocity. So it's going to be 120 cosine of 3. Is there anything else affecting the horizontal? No. No wind or anything else that we talked about. So that's it.
T.
All right. What is the... Oh, times what?
T.
Times t, because it depends how long you're in the air on how far it's going to go. All right, what is the vertical component? 120 times the sine of 3 times t plus or minus. Okay, what? Minus the gravity factor, which is what? 1/2 gt squared, or in this case would be 16t squared, plus 6 feet, because it's starting at a height of 6 feet. Okay? So that would be the vector. To calculate whether she hit a home run, you'd need to use a calculator for this. And you'd let this be, you'd use parametric equations, huh? And you'd let x equal this number, y1 equal that number. Can we just use calculators? Yeah, use the calculator. Okay, let's see, because we probably could solve it. Because in solving this, what would we have done? We would say 100 has to equal 120 cosine of 3 times t. And then 15 has to equal this. Sine of 3 times t minus 16t squared plus 6. And well, that's what the height. Okay. Yeah. Basically, you would solve this for t, plug it in here, and see if it gives you a number bigger than 15 or less than 15. Yeah. Okay. So let t equal 100 divided by 100 cosine of 3. Take that, plug it in here and there, and then see if your answer is bigger or less than 15, and then it would use it. Okay? Anything else?
Sorry, what's just okay? Yeah, that's, I know it's 10.1, but auxiliary gravity.
It was parametric line, right?
Yeah.
Okay.
Is that going to be on the board?
I don't think so. But it's good to know.
It's like
Okay. There's a couple questions in one. I won't be on the quiz or the test, but you should remember how to draw a segment using parametric equations. Here you've got a segment. You've got an ant that starts here, and you want the ant to end up there in a certain time period. You can choose whatever you want to be the time period. And then your parametric equation will depend on how long it takes you to get there. So usually you pick something easy, like it takes you 1 second. So let t equal 1 second. So that means at the beginning, for your parametric equations, you want it to be 1, 2. So it's going to be 1 plus something times time, but time is going to be 0. And it's going to be 2 plus something times time, but time is 0, so it gives you the 1, 2. Now, after 1 second, we want this equation to give you a 4 and a 5. So we want x to be 4. 1 plus a times 1 second. A has to be 3. So the equation that gives you x is 1 plus 3t. In 1 second, we want the y to be 4, and it's going to be 2 plus b times 1. So b, by coincidence, also is 3. And so there would be your parametric equation that produces a line segment from point A to point B in 1 second. Okay, here is quiz 10.4 to 10.6, not part of the notebook check. But kind of good practice on the types of questions.
No, it's not.
No.
Sorry, do you need it? I'm not gonna use it during the hour. I just need
You're welcome.
Yeah.